Hey, this is Flo from FloProDev. In the world of web security, broken object-level authorization consistently ranks as the #1 issue on the OWASP vulnerability list. The Open Web Application Security Project is a global nonprofit dedicated to enhancing the security of web applications. To address this significant issue, Amazon has developed a new approach called Amazon Verified Permissions, leveraging the open-source language Cedar. This methodology aims to offer a more robust solution than previous approaches, like access control lists and role-based access control. As organizations expand, they face a growing number of resources and users to manage. To tackle this complexity, a new trend has emerged in the form of policy as code. This approach is designed to be more scalable, flexible, and auditable than traditional methods, making it ideal for modern dynamic organizations. Now, let's discuss Cedar. Cedar is a stateless language, and its policies are run by an evaluation engine that follows the PARC Model. The PARC Model stands for Policy, Action, Resource, and Condition, and it's an integral part of Cedar. A policy statement must include an effect, which can be either permit or forbid. It also needs the scope that specifies the principles, actions, and resources. Optionally, the policies can also include conditions, which are articulated in a when or unless clause. Let's see an example. This sample code represents a policy that permits a user named Alice to use a photo named Vacation Photo 94. Now, let's see how we can implement this in Python. We start by importing the Bodo3 package. Then we can instantiate a verified permissions Bodo3 client. We can use the isAuthorized function, to which we are passing in the policy store ID, more on that later, the principle, the action, and the resource. As a result, we get a Boolean structure that tells us if the authorization was successful. Apart from permitting certain actions, you might want to explicitly forbid some. This is where forbid policies come into play. These act as a guard, preventing certain actions. Sets in Cedar are a mechanism that allows a policy to apply to all actions within the set. Here's how you would use it. If the scope in a policy is left undefined, the rule applies to all principles. This might be useful in cases where a rule needs to be applied broadly. Groups are also a useful feature. In this example, they allow a rule to apply to all roles within a group. It can be anything, not just roles. Another interesting feature is attribute-based policies. They can permit any principal to perform an action on a resource, as long as certain conditions are met. In cases where you might have more complex evaluations, you can also pass in additional data in the form of context. This can be data such as OpenID or JWT tokens. The context is always supplied as part of the request. Another key concept in Cedar is the schema. It's a formal declaration of the names and structures of your entity types. It's identified by namespaces and uses entity types to define principles and resource types. Finally, Cedar allows you to use policy templates. These introduce placeholders that you can replace with the actual values when creating the policies. However, note that placeholders cannot be used for actions or in when or unless clauses. Thus, a policy can either be static when you create it right away, or linked to a policy definition. This comes in handy if you have a lot of policies and want to change something later on. If they are linked to a policy template, they will change accordingly. Let's start our exploration by creating a Cognito user pool. In the AWS console, navigate to the Amazon Cognito dashboard and hit Create User Pool. For our example, we're not selecting federated identity, and we'll go for some simple sign-in options with username, email, and phone number. You can choose these as needed, leave everything on default, and hit Next. We call our pool Pet Shop and use that as a minimal example to demonstrate the power of Cedar. Enter an app client name as well. Then go to Create User Pool. Go to the Amazon Verified Permissions dashboard and hit View Policy Stores and Create New Policy Store. Next, we will use the guided setup to create an example policy. You'll start by clicking on Create Policy Store and entering a namespace. The resource type for our example will be pet. Of course, in your applications, this could be anything, for which you need to set permissions, such as images for an image hosting service or invoices for billing management. You will then need to define actions and attributes for this resource. From here, you can either create a custom identity source or connect to a Cognito user pool. For our purposes, we connect to the user pool we just created. This will allow us to define policies based on a number of attributes. In our case, we will use the standard policies from our Cognito user pool. For our pet store example, we'll create a policy allowing employees to read resources of type pet to define actions that are allowed. We can use sets specifying actions such as delete, read, update, or we can allow all actions. The policy validation mode determines whether policy changes are validated against the schema. I highly recommend leaving these on unless you're in the process of migrating to or from another identity pool. We should also note that you can edit schemas directly in the console, giving you flexibility to adjust your policies as needed. The console also includes a test bench where you can test actions. For example, you might want to verify whether employees can read pet resources. This has been Flo from FlowProDev. If you found this video helpful, give it a like and subscribe to stay updated on new AWS features.